Hello everyone. So this is going to be section 2.1 and 2.2. So basically I'm going to combine two sections in one lecture as this is mentioned in the schedule as well. Um, all right, so yeah, this is Thursday lecture. Uh, okay, so before I start the lecture, one more time, I just want to remind you guys about the exam, which is going to be next Thursday, which is September 10th. It will be during the regular class time, as I've been saying this from the first day of the class, that your exam is going to be during the regular class time. All right, so uh, even though I've been uploading videos on YouTube, but for the exam, well, this is a hybrid course, right? It's online plus hybrid. So for the exam, I decided to do it during the regular class time, but it will be online. Definitely, it will be online. Uh, I will be uploading, I think I have mentioned this on one video. I don't remember if I've done that, but I will be uploading the exam here. I'll be uploading the exam here. I don't think you can see this tab right now, but once I upload it, you can see the exam. So if you click there, you'll see the exam there. Do the exam and upload your work. Again, the same place, right? So yeah, it will be during the regular class time. You will see the exam at 5:30 p.m. and the due will be 7:15. I think it's not clear. 7:15. 1 5. Oops. But yeah, anyway, 7:15 p.m. So you will get 1 hour 45 minutes time to complete your exam and also upload your exam. So if you don't submit your work in the Blackboard uh, by this time, you won't be able to submit your work. All right. So if there is any problem with the Blackboard, email me. But email me before this time. If I get your email after this time, I'm still not going to accept your exam. Just be clear on that. All right. And um, yeah, you have to, like I said, if you do not submit your work with it by this time, you won't be able to submit your work. All right. And the exam is going to be over, yeah, everything that I cover in chapter 1 and also section 2.1 and 2.2, which is this lecture. All right, so 2.1 and 2.2 is today's lecture. And also web assigned homework, as I think I have mentioned this on the email as well. So 1.6 and 1.7 homework is due this Saturday, which is September 5. And also another one, 1.8 and 2.1 and 2.2 will be just one homework, all right? 2.1 and 2.2 will just see one homework. So these two homework will be on Wednesday. Since the exam is on Thursday, so these two homework will be due on Wednesday, the day before the exam. And also this Monday, there is no lecture, so I won't be uploading any lecture this Monday because I think it's a Labor Day weekend. So yeah, you won't see any lecture on that day. Since I have office hour on this day, right, and your exam is on Thursday, so maybe some of you guys might have some questions. So the Monday office hour, I will make that office hour Tuesday. So just for next week, just for 1 week, Monday office hour will be on Tuesday, the same time. All right, same regular class time. All right. So that's why I don't have office hour this Monday. Okay. All right. Let's start the lecture, section 2.1 and 2.2, which will be about the derivative. All right. So before I start the derivative, we need to know a few concepts here. All right. So now let's just make a random grab something like this. Let me just pick 2 points on this graph. And let's say this point is a comma f of a. And let's say this is x comma f of x. All right, so this is one point, this is another point. All right, and if this is a, if this is x, then this should be x minus a, right? Okay, now if 2 points are given like this, then we can find the slope, right? If you go back to algebra, we know the slope equation is y2 minus y1 over x2 minus x1, right? So here we need to do, we need to use a similar concept. So here I can assume this point as x1, y1, right? x1, y1, x2, y2, right? And I think I also mentioned in one of the video that a line that goes through the 2 points on the graph, these kind of line we call a secant line, right? A secant line. This kind of line we call a secant line. And if there is a line that just touch the graph at one point, then we call that line a tangent line, right? But here now we are trying to find the slope of the tangent line. So the slope of the tangent line at this point, a comma f of a, right? So here, slope of the tangent line are basically, the tangent line will be just a line that goes through, okay, since we are trying to find a tangent line at this point, so that means this point should go to here, right? So, or this point should approaches to here, so that way we get a tangent line that goes through this point. There will be a line. There will be a line. This is a straight line that will just touch this point here. So now this line is called a tangent line, right? So the tangent line, okay, so the tangent line is, okay, the slope, right? The slope, we can also say slope m, right? Here we can say slope m. So the slope is equals to, is x2, y2 minus y1 over x2 minus x1. So y2 minus y1 is f of x minus f of a over x2 is x and x1 is a. All right, so here we found the slope of the secant line, right? Because we have 2 points. So we found the slope of a secant line, but we are trying to find the slope of a tangent line. And we can find the slope of a tangent line if we can say that this point approaches to here. So if this point approaches to here, we'll get a tangent line. So that we can say that if this point approaches to here, we can say that x approaches to a. So the limit where x approaches to a. So this will give the slope of the tangent line at this point. Okay, so that's a formula of finding the slope of a tangent line. All right, so if that's the case, then let's find, okay, let's do an example. Let's find an equation of the tangent line to the parabola y is equals to x squared at the point 1, 1. Okay, so we are now trying to find the equation of tangent line. All right, equation now. So we know that from algebra that the equation we used to use there was y minus y1 is equals to m times x minus x1, right? Or here, okay, so here we have a point given, right? So if a point is given, then we can assume that point as a comma f of a. Or simply, and if it was algebra, then we would have say x1, y1. But here in calculus, we're going to say this as a and f of a. Okay, so that means we are going to get a new formula here, right? So new formula would be something similar, y minus y1 instead of y1, we get f of a is equals to m is a slope, and x minus x1 is a. Right? So now, okay, so that means we are trying to find an equation. So that means when you find an equation, we need to find, okay, from this formula, we need to find the value of everything except y and x. Because when you're finding an equation, equation should be in terms of y and x. We should have a variable y and x in the equation. So that means it is the equation of something, all right? Okay, so that means we know the value of f of a, which is 1. We know the value of a, which is also 1, but we don't know the value of m, but we can find the value of m, right? We know the formula from here, this one, right? Let me write that here again. Limit of x goes to a, f of x minus f of a over x minus a, right? So, all right, let's find, the m, right? So now limit of x goes to a means 1, right? And f of x is, well, y, we can also say y as f of x. Why you can say this? Because we can say f of x because we have equation in terms of x. That's all. I can also say that f of x. All right, so f of x is x squared minus f of a is 1 over x. A is also 1, right? So now after this, it looks like when I say x goes to 1 in the denominator, we will get 1 minus 1, which will be 0, so we'll get something divided by 0 undefined. So that means here we need to simplify, or we need to find the factor of this thing, right? X squared minus 1, but we know that a squared minus b squared is a plus b times a minus b, right? Here I can say that once 1 is also 1 square. So this way I get on the top. Okay, like I've been saying every time that we haven't still used the limit, right? So you need to write the limit every time. All right, so you need to write the limit, and after that you need to work on this. So now x squared minus 1 squared is x plus 1 times x minus 1 over x minus 1. Okay, now I can cancel this too. So the limit of x goes to 1 of x plus 1, right? Now after this, we're using the limit, right? So the limit where x goes to 1. So if x goes to 1 here, it will be 1 plus 1, which will be 2. So that means the slope m is 2. All right, so that means we found the value of m. All right, now that means we can find the equation. All right, so from here, y minus f of a is 1 is equals to slope is 2, x minus, again, a is 1. So from here, y minus 1 is equals to 2x minus 2. So 8, 1 on both sides. So y is equals to 2x minus 1. So this is the equation. Okay, so this is the equation of the tangent line. Okay, now okay, now let's define derivative. Okay, so what exactly the derivative means? So the idea of the derivative is pretty similar to the idea of the slope of the tangent line. Or we can also say this, that derivative is also a slope. So derivative means it is the slope of a tangent line at certain point. All right. So let's say so here the actual definition of the derivative is pretty similar to uh, the definition of the slope, but there is a slightly variable changes, but you will understand it. Let me. That's the standard way of writing the definition, so that's why I'm just gonna explain the same thing. Okay. Now let's say, okay, there is a line, just a random line with 2 points. Which at this point is a, comma, f of a. Right, there is another point. So let's say from this point to this point, the x value, the change in x is h. All right, so that means here, this point would be, if this is a, then the here x value would be a plus h, that's x, comma, and another one, if this is f of a, if this is h, then another, the y here would be f of a plus h, right? And like I said, the derivative is the slope of a tangent line at certain point, all right? Here, if you go back here, we said that this change is x minus a, right? That's right, right? Because if this point is x, if this point is a, then the length of this would be x minus a. But simply, instead of writing x minus a, we could have even write just one variable h, right? We could have done that. So that's what I'm going to do here. That's what I am doing here. Instead of saying x minus a, I'm just writing h. Okay. Now, there's the slope would be y2 minus y1, right? Which is y2 is f of a plus h, minus x1 is f of a, over x2 minus x1 would be a plus h minus a. And the limit here, what would be the limit here? So the limit here is going to be basically, here we said that the limit is that x goes to a. So if x goes to a, then that means here if x goes to a, it will be a minus a, which will be 0. So basically, if I say this is h, we're saying that h is going to 0, right? Understand? We're saying x goes to a, so if x goes to a, then this point approaches to this point, so there won't be any changes, so that means the h, the changes would be 0, right? So that's why this change, since we are trying to find, so this is a second line, but we are trying to find the slope of a tangent line, so this must approaches to here, so where h is going to approach to 0. Okay, so like I said, the derivative is also the slope, of a tangent line at certain points. So now instead of writing slope, I'm going to introduce the derivative term. So derivative, we're trying to find, so here, since if this point approaches to this here, right? So we are trying to find the derivative at this point. So the way we write the derivative would be f, something like a dot or an arrow on the top, which we say f prime. And since we're trying to find at this point, so we'll take the x value a, f prime of a. So this means the derivative at a, or we can say f prime at a, f prime at a. Okay. And on the bottom, we see that a, and we have a negative a, so this cancel out, so we get only h. All right, so this is the formula of derivative, or we can even say this is a definition. So this is the definition. Definition of derivative. So in the exam, I might ask you to find a derivative of a certain equation using the definition of derivative. All right, so let's do an example, something which we'll talk about this. Okay, so so f of x is equals to 3x minus 8. All right, and then I need to find f prime of x. Okay, so f of x is given. Now I need to find f prime of x using the definition. Using the definition of derivative. So the definition, as I said, is right here, right? So here, one thing here, we have f prime of a, right? But here I'm asking f prime of x. That doesn't make difference. Now all I'm doing is I'm changing x, or I'm changing a to x. So that means if I change this a to x, this should be x, this should be x. So that means our new equation would be f prime of x is equals to limit of h goes to 0 of f of x plus h minus f of x over h, right? So now, now what I can do here is, okay, so I know f of x, so that means I can also find f of x plus h, right? So let me do that here. F of x plus h would be 3. Now instead of x, I'll get a new term, which will be x plus h, right? So that way we'll get 3x plus 3h minus 8. All right, so now again, make sure you write the limit here again, because we haven't used the limit yet, because we cannot use limit at the beginning. We have to simplify everything, and then after that, at the end, we need to use the limit. Okay, so yeah, make sure you write the limit every time. So h goes to 0, f of x plus h is 3x plus 3h minus 8 minus, all right, so this minus, and we have f of x. So make sure this minus is going to be distributed to both of this, 3x minus 8, right? Because f of x is 3x minus 8. So you need to distribute this minus to both of this. So make sure you don't make mistakes there, because I see few students make mistake there. They just take the minus here. They don't take they don't multiply these two, this minus and this minus. Okay, again, we haven't used the limit here, Ed. So now after doing that, after distributing this, I get minus 3x, and here I get plus 8, right? So so that means this cancel, this and this cancel, so we get only 3h over h. So h and h cancel, so limit of h goes to 0 of 3. So limit of something goes to something of just the number, then it will be just that number, right? So after this, let's say, okay, so as I found the f prime, right? So I found this. So after this, I might ask you, let's say, I might say you, like I asked you here, find an equation, right? So that one we found is, so let me write that here again, y minus f of a m times x minus a. All right, so here we found the slope, right? But we don't know the point, right? F of a. So I might ask you, let's say, I might ask you to find the equation of a tangent line with same equation at certain point. Let's say a point would be, let's just say random point 3, 2. So in that case, now I can assume this as f of a, sorry, this would be a, this would be f of a, plug that in here. We know the slope, right? So if this is a, if this is f of a, then now we can find the equation, right? The equation of a tangent line, y minus f of a is 2. This is 3x minus 3 again, right? So then you can simplify, and yeah, you'll get the answer, right? So yeah, that's the idea of getting an equation. Or if I simply ask this, your answer would end right here. You don't have to say anything. If I simply ask find the derivative, or yeah, something like this, find the f prime. So I will specify use the definition. So you have to use this process, all right? So this is how you're using the definition, because there is a definition right here. So we use the definition, right? So yeah, this is how you need to get the answer. Okay, now let me ask you one quiz problem, okay? I haven't asked you a quiz in a while, so let me ask you one here. So let's say f of x is given x squared, and you need to find f prime of x. Again, using the same idea, using the definition, right? Using the definition. Definition of derivative. All right, so using the definition of derivative, you need to find f prime, or the derivative of f of x. All right, so this is a quiz problem. All right, is it clear? This is a quiz problem. because I get few email from few students saying that, oh, I didn't see the quiz. If you actually watch the whole video without skipping anything, you are definitely going to see the quiz problem. If you don't see the quiz problem, maybe you didn't listen carefully what I'm talking about, or you just opened the lecture video and you're doing something else. So that's why you didn't listen the quiz problem I said. But if you watch the whole video carefully, then you are definitely gonna see what I assigned the quiz problem. All right, it shouldn't be a problem. You're definitely gonna see it. All right. So again, I have made it clear this is a quiz problem. So okay. So that means since this is a Thursday lecture, right? So the due would be, so the due for this one is going to be the next day, Friday. All right. So the due for this one is going to be tomorrow, Friday, midnight. Right. That's how the quiz due is set up. Right. Okay, so here again, you need to use the definition, this definition or this formula for this one, right? All right, so do it. Do this as a quiz problem. Okay, now another one is derivative notation. So there are different ways you can write the derivative, right? So here, let's say y is equals to f of x is given, right? So y is equals to something, or you can even say y is f of x, right? So that means the derivative, the way we can write the derivative would be, there are a lot of things, a lot of ways you can do that. So as I said here, the derivative, first one, you can say like this, f prime of x, which means we are taking the derivative of f of x. Or since y is equals to f of x, we can also simply write y prime like this. So this means it is a derivative. Or we can also write dy over dx. So that means we are taking the derivative of y over dx, means we are taking the derivative of y in terms of x. All right, since y is equals to f of x and this function is in terms of x. So when we are taking the derivative of y, we need to take the derivative of that y in terms of x. So that's why we have dx in the denominator. All right, so, or we can also write d of f of x over dx. Or there is another one. There is, we can write a capital D of f of x. We don't use this notation that much. Most of our notation you will see in the class would be this 4. But in case if you see this notation, don't be surprised. All right, so this means the derivative. Or you can also write dx. This x is going to be in the bottom, or a subscript f of x. So this means again we are taking the derivative of f of x in terms of x. Like I said here, in terms of x for this one, or you can even write like this. But again, I will be using this kind of notation a lot in this class. But again, if you see this thing, don't be surprised. Okay, you might see this, but yeah, but I'll use this most of the time. But it's still good to know, right? It will be useful for the future as well. Okay, I think I have mentioned everything that I want to talk about, at least for exam 1. I will, you will see the review, the exam 1 review. I don't know, maybe, I don't know. I haven't made the review yet, the time I have made this video, but definitely I'll make the review now. After I'm done with this recording, I'll start making the review. But anyway, I will see you on the next video. All right. Thank you.